About radians on the unit circle and where all the radians are on the unit circle, it should be really easy to evaluate expressions like this. You know they're in radian mode because the pi. To evaluate expressions like this without a calculator, if you have your unit circle, it really is a piece of cake. Sine of pi over 3. Okay, pi over 3, that was the same as 60 degrees up here. If you rotate on or spin along the unit circle, it's 1/2 comma square root of 3 over 2. Remember, the cosine is the x value, the sine is the y value. So our answer is square root of 3 over 2. It really is that straightforward. So if I ask you for the cosine of pi over 6, we know we're in radian mode because the pi. Pi over 6 is in quadrant 1. It's just a little rotate, the same as 30 degrees. That ordered pair is root 3 over 2, comma 1/2. And since it's asking for the cosine, it wants the x value. So it's going to be square root of 3 over 2. And it is a coincidence that I chose two problems that have the same answer. This one will not have the same answer. The tangent of pi over 4. We haven't talked about tangent as much. Pi over 4 is here in quadrant 1, square root of 2 comma square root of 2. Well, the sine or the cosine is the x value. The sine is the y value. What's the tangent again? Try to remember tangent is y over x, or think of it as the sine over the cosine. So here, the y value was square root of 2 over 2. The x value was also square root of 2 over 2. So that simplifies to 1. So the tangent of pi over 4 is 1. Let's try a few more. No calculator needed. It's really pretty simple. Cosine of 2 pi over 3. Well, 2 pi over 3 is way over here in quadrant 2. The cosine would be the x value, so I would have negative 1/2. All right, how about the sine of 11 pi over 6? 11 pi over 6, that's way over here in quadrant 4. It's almost at 2 pi. The sine would be the second, the y value, so I've got a negative 1/2. Makes sense to me. In quadrant 4, the y value is negative, the sine value is negative. All right, how about tangent of 3 pi over 4? 3 pi over 4, that's over in quadrant 2, because it's not quite 1 pi. 3 pi over 4, it's right up here at negative root 2 over 2, comma root 2 over 2, and it wants the tangent, so I have to do y over x. So this time I've got root 2 over 2 is my y, over negative root 2 over 2 is my x. So that's just going to equal a negative 1. So the tangent of 3 pi over 4 is negative 1. No problem. All right, a few other things that you're going to be asked to do. It's kind of good to know for trig. This doesn't necessarily have to do with the unit circle, but actually, never mind, it totally does. All right, you are going to be asked to find one positive and one negative coterminal angle for the given either degrees or radians. If you remember, coterminal means having the same ending. So if I just did a little sketch of this guy, I can really quickly get a sense of what's going on. 150 degrees, I remember we always start in that positive x-axis. 150 degrees is going to end over in quadrant 2. Just like that. Now, a coterminal angle means that it's another angle that also ends at this same spot. So let's keep going. If we go all the way around to 360 and another 150, that angle would be coterminal. So if we did 150 plus a whole nother full rotation plus 360, it would be 510 degrees. All right, and then a negative one says, okay, I'm out here at 150. A negative coterminal angle would say, let's go the other way around in that negative direction. So I'm starting at 150, and if I go in that negative direction, I go negative 360 degrees, I end up at negative 210. So basically what's happening, it's saying that negative 210 degrees, 150 degrees, and 510 degrees all have that same ending side. They all have the same beginning, same ending. All right? Now, it's not hard to do this in radians. So when we were doing positive and negative coterminal in degrees, all you're doing is taking that and adding 360, subtracting 360. No big deal. That's one full rotation around. So for degrees, add 360, subtract 360. Well, I think it would make sense when you're in radian mode. A full rotation would be 2 pi. So you're going to add 2 pi and subtract 2 pi. So let's think about that. 8 pi over 9. Well, 9 pi over 9 would be right here. So 8 pi over 9 will be just in front of it. So it's also out in quadrant 2. So we've gone 8 pi over 9. If we go a whole nother 2 pi, we'll get that same coterminal angle. So 8 pi over 9 plus 2 pi, that's not so hard to do. If we take the time, let's get a common denominator. 8 pi over 9. Well, if I multiply top and bottom by 9, it's going to be, the equivalent is 18 pi over 9. So when I add them, I get a 26 pi over 9. Okay, so far I know 8 pi over 9 and 26 pi over 9 have the same coterminal angle. And let's try then going the back way around, backwards, a full rotation. So we will do 8 pi over 9, subtract 2 pi, or subtract 18 pi over 9, and that would get us at a negative 10 pi over 9. So what that's saying is that negative 10 pi over 9, a positive 8 pi over 9, and a positive 26 pi over 9 all have that same ending coterminal angle, coterminal side. All right, and ask for one positive and one negative. I got one positive by adding 2 pi, one negative by subtracting 2 pi. So that is something I think you guys should be able to handle just fine if they're asking for coterminal angles, one positive, one negative. All right. Then the last thing I want to talk about in these videos is sometimes it's really helpful to be able to convert between radians and degrees. Eventually, you guys will be, right now, I think you're a lot more comfortable in degree mode. Eventually, you'll be just fine in radian mode. But it's nice to be able to think about how they relate. So let's think about that. If we create or want to think about this as a ratio, isn't it true that 2 pi in radian mode is all the way around a circle, which is the same as 360 degrees? That would be a fine way to translate, but I would go even one step further and simplify. I think it would be even easier to use pi over 180. It's just simplify it a little more. But that's up to you. Either of these would work. So basically what you do for 260 degrees, if we were going to convert that to radians, well, if I use that pi over 180, and I was going to say, then I was going to create a proportion. Well, the 260 would go in the denominator because the 180 was in the denominator, and they are both our degrees. And we're trying to figure out what its equivalent is in radians. So when I cross multiply here, 180x equals 260 pi. I'm going to divide by 180. And the 260 divided by 180 reduces all the way down to 13 pi over 9. Don't try to make this pi a decimal or anything. Just simplify the 18 and the 26. All right? You know you're on the right track because if you're in radians, if your final answer in radians needs to have a pi in it. Where over here, if you start in radians and move to degrees, you've got your 1 pi over 180. Well, this time, the 15 pi over 2, that's going to go in the numerator because that's clearly in radian mode because of the pi. And we want to figure out its equivalent in degree mode. So if we cross multiply this, we get x times pi. Now, this looks a little more confusing, but we can do it. It's 15 pi over 2. Well, to simplify, to start, this 2 can become 1. This 180 can become 90 if you wanted to do that. So you get x times pi, then 90 times 15 gives us a 1350 pi. Then to solve for x, it's really nice. The pi's cancel. I get that x, oops, sorry, it kind of is 1,350 degrees. You know, if you're in degree mode, you don't want pi in your answer. If you're in radian, you do want pi. And this is quite a few rotations around 1350, but so is this, because that's almost 8 rotations around. If you changed it to 16 pi over 2, which would reduce to 8 pi, that's almost 4 rotations around, so it makes sense that this would be a big number at almost 4 rotations around as well. That is it for today's videos. Thank you for lasting this long. It will be worth it that you stayed till the end. Thank you so much.